Question 4, we're looking at water waves. The diagram below shows water waves approaching a gap in a sea wall. Classic question, really. Give the scientific name that describes what happens when the waves pass through the gap. Well, it might help to draw what's going to happen when the waves pass through the gap, which is actually question B here, to show the shape of 3 waves that have passed through the gap. So this is going to be a little bit hard to draw, but 1, 2, 3. So the waves are spreading out. The wavelength is the same as what you started with on this side. That's how it should look anyway. Okay, and where are we? Oh, going back to A. So the name for this process, this is diffraction. Diffraction. C. Describe how the wavelength and the shape of the wave pattern changes if the gap width is reduced to half of its original length. You may sketch a diagram to aid your explanation. Okay, excuse me, I'll just cough. Okay, so as we're saying, what's going to happen is with the diagram above, the gap is around about twice the wavelength. But in what we're doing now is reducing it by half, so the gap now goes to about the same spacing as the wavelength. That's when we have maximum diffraction. So what we would expect is the waves would come out with more bend, more circular. So here's our diagram. So the gap spacing in there should be around about the same as the wavelength. That's this spacing here. That should be around about the same as the wavelength of waves. And as it's more circular, the wavelength remains the same. And yeah, that's pretty much it. D. A fishing long line has many hooks attached to it. The line is supported by ropes attached to floats as shown in the diagram. So I guess this is the water, this grey kind of part is the water. And we've got the floats, and there's a wave as we've seen passing from left to right, and the floats are moving up and down with the hooks underneath. Okay, now that I've oriented myself with the diagram, I'm going to go into the question. The floats are spaced 9.0 metres apart, so 9 metres apart, in a straight line. Waves from the sea travel past the floats. It takes 1 minute. 1 minute, that's going to be important, I'm sure, for a crest to travel from the first float to the last float. So that's covering from the first float to the last float. Okay, the wavelength of the wave is 6 metres. Calculate the frequency of the wave. Okay, this could be a little bit tricky. What have we got? We've got the spacing of the floats, 9 metres apart. Do we know how many floats we've got? If we go by the diagram, we've got 1, 2, 3, 4, 5, 6. So 6 floats times 9 metres apart. But that's 1, 2, 3, 4, 5 actual spacings of 9 metres, which would be 45 metres. Okay, takes 1 minute to cover that distance, so 60 seconds to cover 45 metres. So we could work out a velocity if we needed to. Because velocity being distance covered over time, the velocity of the wave would be 45 metres divided by 60 seconds. And we're told the wavelength is 6 metres. So it looks like we're going to have to use our V equals F lambda, because we're trying to find, well, we know the wavelength, we can calculate the velocity, V, looks like a tick as well, and we don't know what the frequency is, and we're asked to find that out. Okay, so I think it's fair to assume that there are 6 floats, 5 gaps of 9 metres between them. It's not strictly speaking clear, but we'll go with that and we'll see what we end up with. So 45 metres divided by 60 seconds to give us the velocity of the wave. which will be 0.75 meters per second. We know the wavelength was 6 meters, 6.0 meters, so frequency from V equals F lambda, frequency equals V divided by lambda, which equals 0.75 divided by 6.0, and gives us a frequency of 0.125 cycles per second, or hertz. We want to see, does that make sense? 0.125 cycles per second would mean that it takes a while. Oh, well, it would take about 8 seconds for one cycle. 8 seconds for one cycle, which, does that seem right when you've got a wave passing? I'm sorry, I've got a lot of noise in my background. When you've got a wave travelling, from there to there, that peak of the wave, which takes 60 seconds to travel all of that distance, we would expect one of those to move up and down around about 8 times in that time, which is roughly what the diagram looks like. So I think that gives us a little bit of confidence in our answer, and our original assumption that this was the number of floats, that's just what we can see in the diagram. But there we go.